When constructing a confidence interval estimate of the mean and the population standard deviation sigma is unknown, we have critical values from the t-distribution. So recall that the formula for the student t-distribution for all samples of size n is t equal x bar minus mu over s over the square root of n. Since we do not know the population standard deviation sigma, we estimate it with the sample standard deviation s. Using s for sigma introduces another source of unreliability, especially with small samples. So in order to maintain a desired confidence level, such as 95%, we compensate for this additional unreliability by making the confidence interval wider. We use critical values t alpha over 2 from the student t-distribution that are larger than critical values of z alpha over 2 from the normal distribution. So a critical value of t alpha over 2 can be found using technology or tables. To identify t alpha over 2, we need the number of degrees of freedom. I mentioned this briefly in the last video. The number of degrees of freedom, and we abbreviate that df, for a collection of sample data is the number of sample values that can vary after certain restrictions have been imposed on the data values. So we'll look at a little example of what we mean by degrees of freedom. If 10 students have test scores with a mean of 75, we can freely assign values to the first 9 scores, but the 10th score is then determined. The sum of the 10 scores must be 750 to get the average of 75, so the 10th score must equal 750 minus the sum of the first 9 scores. So because those first 9 scores can be freely selected to be any values, we say that there are 9 degrees of freedom available. So we calculate degrees of freedom by taking the sample size minus 1. Okay, so to find a critical value, a t-value, using technology, we need the confidence level and the degrees of freedom. So let's look at an example. Let's say we want a confidence level of 95%, and let's say our sample size is 10. Okay, then with a confidence level of 95%, alpha equals 0.05, and alpha over 2 equals 0.05 over 2, or 0.025. So the way we would write this notation for our critical value is t alpha over 2, you'll often see comma degrees of freedom. So I would write this t 0.025 comma 9, because our degrees of freedom here would be 10 minus 1, or 9. So here's what we're looking at. We're looking at a distribution, and we'll discuss this a little bit more, but the mean of the student t-distribution is 0. It is bell-shaped, and we have our critical values with alpha over 2, or 0.025 here, 0.025 here. So the structure is the same as with the normal distribution. And then to use TI-83 technology, we're going to use the keys. We'll need our distribution key and then the inverse t function. And so in this case, we'll say inverse t parentheses 1 minus 0.025 0.025, that's our alpha over 2, and our comma degrees of freedom. That's how we enter this. Okay, well, let's pull up the calculator and see. Okay, so we use our distributions, tab down to inverse t. Our area here is 1 minus 0.025. Our degrees of freedom, 9. And paste, enter. And we get our critical value of 2.26. Or 2.262. We'll go to 3 decimal places. 2.262. Okay, and that's how you can find your critical values using technology. They also can be found using tables.